Hi guys, welcome to Learn Electronics Repair and a revisit of the HDMI Breakout board. I made a video with this a week or so ago and I made at least one mistake in that because I was actually probing the wrong points on the board. So I was actually looking at the LVDS, the data on each of the lanes. There's 3 effective lanes here of data in HDMI. And by the way, this is the same principle that is used for SATA, is used for USB, PCIe, but I had the probes in the wrong place. So for each data lane, there was a plus and a minus signal. This is a differential system, so it's the difference between the 2 signals that effectively create either a logic 1 or a logic 0. When I say a plus and a minus, really that is more like an op-amp nomenclature, so it's actually an inverted and non-inverted signal for each lane, the 3 of them. And I was actually probing the inverted line of lane 0 and the inverted line of lane 1, so I completely messed this up, probably because I put the jumpers in the wrong place to kind of remind me of what's what. So now you can see we have the 2 green jumpers here and the black in the middle. The black is ground and then the 2 green are the signals. So 2 of the conclusions I came to last time I was looking at this is, one, that if you have a static image on the HDMI, it doesn't continually send the data over and over. It appears I was wrong. That's what seemed to be happening, but no. And also that the 2 signals of the LVDS were always in antiphase. Again, that's also not correct. So I've now attached my scope correctly to this. So let's have a look to see what actually does happen. Firstly, a quick word from our sponsor, PCBWay.com. PCBWay are a manufacturer of all sorts of PCBs, small ones like this, double layer, multi-layer, flex PCBs. They make them all and they have a very easy to use and friendly service. We can see here the PCBWay website. From here you can get a quotation to make your PCBs, but generally speaking, for a PCB like the one I'm just showing you, you'll pay $5 for 5 PCBs, and postage, well, to here is just less than $5, maybe $4. If we want to wait a little while, that's a sort of normal postage. It takes maybe a couple of weeks. We can have express postage, of course, as well. If it's urgent, pay a little bit more, but the thing will get here extremely quickly. Normally, I get PCBs sent to me from order. It takes about 6 days. That's actually making and shipping to reaching my door. And that isn't the fastest service available, but it's a very good one. Another great thing about PCBWay is they have the shared projects section. So with the shared projects, this is where you can upload your own designs. This is what we will do with this HDMI tester when we finish the development on this channel and the daughter boards that we're hoping to make to fit on it. So if you do that yourself, or we do that, then it's very easy for anybody to order the PCBs with just one click, and the author gets a 10% commission on the sale as well. So that's great. It means you can get your own ideas and projects out there. You don't have to stock PCBs. You don't have to worry about shipping them out or will they sell. Any that do sell, you get a nice little earner from it, okay? Another great thing with PCBWay.com is if you are a new customer, when you first sign up, well, have a look in the description to this video. You will find a discount code that gives you $5 off your first order. So if you were just making PCBs like this, 5 for $5, in fact, all you will actually do is pay for the shipping. And that's an unbeatable offer. So this is where to get your PCBs from. Now let's have a look at the project that we're working on, the HDMI Breakout and test board. I have the probes on channel 0, plus and minus, or if you like, non-inverted and inverting, and we can see the 2 traces on the scope here. Now that's with a static image on the screen, so I have the HDMI connected to a computer and then the output to the monitor. This is sitting in between. So we're feeding the signal in here from the computer and out here to the monitor. And if I just stop that, you will see that we have the two signals, and they're not always in anti-phase with each other. You can see that they're rising and falling at different times. Just go again, there. So this is not random data, but it actually sends like the whole screen. So I'm just stopping it at different times, basically. And that gives you an idea of what we get. Now, I'm going to just run a benchmark on the computer so we actually have some moving image. There. And you can see we basically still have the same sort of thing. So data is being sent continuously. Just adjust the time base there, you can see it. Let's just stop the moving image again. Back to the desktop. And we just have different data. We looked before like we had data or none, but that's because I was probing the wrong places. Just start the demo running again. And there you have the signal. So the idea of this is really for, if you like, exploration of HDMI. We can have a look at the signals, we can learn quite a bit about how this works. But it does have other uses as well. One of them is that we realise we can make this into a cable tester very easily. So if you connect a HDMI cable from one end to the other, and you take all these jumpers off, first of all, you can go down with a continuity meter all the way down here, and you should see continuity on each line. But that wouldn't tell you if you had a short between two lines. So one idea was that we could fit a daughter board on this that effectively pulls through each of the lines or sends a certain pattern with certain lines high or low and monitors what comes back, and that could determine very quickly if we have a good or a bad cable. We can make a go or a no-go test. So that was one idea we had with this. Another idea was we could use this to connect to a video source, say a graphics card or something like that, and by measuring the resistance effectively on each line or in diode mode on each line, we can determine whether we have a good or bad port physically. It doesn't mean it can send data out or there's a problem or not with the graphics card, but it tells you if the connection is okay to the other end, to the HDMI. Seeing as that actually goes directly into the graphics card pretty much at the other end, that might be a useful test as well. So those are some of the things we had in mind we can do this. And when I say we, I mean Detlef and myself. So it was the two of us who effectively came up with this project. And today I have Detlef with me, so we're going to talk about some of the ideas we have with this and hopefully some of the ideas that you have with this. So let's get Detlef in and then let's have a chat. As promised, I have Detlef.
Good day.
And I
Hey,
thought
nerds.
you were going to say hey nerds as well. So we're going to have a chat about the daughter board that we are going to make to fit onto this. The idea is, as explained, we can test cables with it, we can test ports with it and such like. But to be quite honest, guys, a lot of this are just our ideas at the moment.
Yeah.
So it's very important to us, at least, that you guys want to get involved with this. So please get into the comments below, lots of suggestions. Let us know what you think about what we've discussed today, whether you think it's a good or bad idea, and hopefully some extra ideas to add to them. Okay, so I'll pass over to Detlef right now. I'll still be here. And let's have a look at this daughter board.
Okay. Yeah, we played around with the idea to do more with that. This started as a simple cable tester thingy, and I was a bit drunk when I layouted the board, and I know there should be squiggly lines to keep the lines all in the same length. For a contingency tester, this doesn't matter.
Yeah. Actually, there's another thing on this as well. So, a very short story. Detlef actually designed this when we first met before we lived here. He was on holiday here at the time when he designed this.
I was sitting in my hotel room. These guys got me drunk, and I was layouting these things. This is why there are no squiggly lines.
And you can tell because when Det first brought this to me, and he says, "Oh, the problem with this is because effectively the opposite way round. So pin 1 on this is like." Pin 1 down there. I straight away said, but Det, why don't you take one of the HDMI connectors like this, and you can also get ones which are the other way up, so the flat part goes down to the board, and if you put one the other way up here, then all the pins read 1 to 19 on both and the lines are straight. And Det's answer is, come on, Rich, I'm on holiday, it's done. So that actual fact is possibly, if we were going to make the lines all the same length, we would actually fit one of the HDMI connectors of the other type.
Yeah, we probably would redo this. But, since this is a thing that you're going to use, I'm a bit on the fence here to do a big redesign here because guys, right now we need a good use case for that, and that's what he came up with the idea to do a cable tester thing here.
Yeah, and then the port tester.
Then the port tester, yeah. Cable tester is more around this board, and Rich told me, okay, I want to have something where I can simply plug in a cable and it tells me cable's good, cable's not good, and I think we can do this. We're going to set there a daughter board that sits on the outer pins, the pins that are not connected right now. So the outer, and of course you won't populate the jumpers in the middle, because we would do this electronically there. And we were talking about this, and I said, okay, yeah, sure, I think I have an idea for that. And then we came up with a little layout, and I think we're going to switch now to that.
Okay, let's have a look at it. So here is the daughter of learning electronics repair and Det build stuff.
Some sort of a love child,
So Det, explain this, and we have a schematic too. So
we have a schematic for that. What I was thinking here was, okay, I need to be able to test every single pin here. So we have 19 by 2, so 38 pins. I could probably use a 80 mega 256 for that. I think it has enough pins.
Yeah.
But since we want to keep this buildable for you guys, so we thought, okay, let's do something everybody has somewhere lying around. So it's turned into a Nano. Of course, I use a Arduino Nano that will be our main controller on that one. Mm-hmm. And then we have I2C multiplexes over here. What the heck is an I2C multiplex? I2C is a serial bus.
Yes.
It's only 2 wires. This is actually these 2 wires down here. You see this little pull-up resistors over here. These are my I2C bus wires. And these are GPIOs. In fact, it's 2 times 8, 16 GPIOs on every of these multiplexes here. So I have 16, 32, and then I was lazy. I simply threw in the same chip again because with this, I can connect every single pin here to ground. I can connect it to VCC.
Yeah.
I can use it as an input with a pull-up resistor. This is very interesting because with a pull-up resistor, I simply can use the other side of the cable to pull it down. And if it pulls down, I know this cable is fine. Mm-hmm. And I can do this for every pin now. In every direction.
Do you have a schematic for this?
I could show you a schematic for that, yeah.
Okay. Oh, okay.
Well, I don't know if this really helps.
Oh, this is one of Det's schematics with nets everywhere and no wires.
Yeah, you know me. I'm the net guy here. It's nets everywhere.
Yeah, wires are overrated.
And imagine drawing this with wires. You see this. This goes somewhere over here. And drawing this with wires, it would be one big clump.
Yeah.
You would only see wires. Yeah? This is only a green thing now. And this way I could come up with how do I do this the best way. In fact, the routing here is optimized for less crossings.
Yeah.
In the software we're going to have a long table that translates between pins, so we don't have to. We only have to look at this once more, not anymore again. And this is going to be a big thing, yeah.
Yeah.
So what you see here, I simply go from one GPIO and I go over here to some of these connections over here.
Yeah.
This is the way how this is done.
Okay.
And,
so you're saying on the GPIO chips that the signals are not in the same order as the ones on the pin header.
Yeah.
You've done it so that you can do the routing most easily.
Optimized for routing, yeah.
Yeah.
This is a way to do that. You could go, okay, I want to do this straight away, like one pin should be the pin over here, but that would make your layout way more complicated.
Yeah.
It's easier to do this in software.
Mm-hmm.
Back to the thing over here.
Okay.
So I needed 3 of them because I have more than 32. So there are a lot of unused pins on the lower one over here on number 3.
Yeah, on number 3, I've noticed that the chip is mounted, if you like, on the board upside down.
Yeah.
Oh no, number 3 and number 1 are the same, and number 2 is the other way up.
Yeah.
Is that just again to make the routing easier?
Yeah. This was this came out like that.
Okay.
Let's say it this way.
Okay. So what are the little square things in between the 2 rows of pins?
Oh, I'm really proud of those.
Oh, those.
Yeah, I'm really proud of those. These are little LEDs. These are RGB LEDs.
Okay. With 4 pins.
Yeah. You know these addressable, the guys outside probably know the RGB LEDs you can use as lighting thing. The WS2812.
Mm-hmm.
These are 5mm by 5mm in a squarish package. You have 4 pins. One is data in, one is data out, VCC ground.
Oh, so you don't have like VCC then, red, green and blue, like 4 wires on a normal?
No.
Well, there are 4 wires, but...
If you look down here at the layout, you see... oh, come on.
Huh?
You see here's VCC, there's ground, this big fill over here, and then there's a chain.
Yeah.
Good. Your mouse hates me. Your mouse hates me very much.
My mouse hates everybody.
Yeah. And it's simply, this is data out, and this goes into the next LED.
Oh, so it's like a serial
this is
data.
a chain, yeah.
A chain.
Yeah. And this, when you're back to the layout over here, there's a big chain. You see, data out goes to data in of the next one, and I did every LED I have on here. I did this with these. So I have a power LED. This probably will turn green when it's on. I have a cable good. Cable good. It's the idea to have this there to do an automatic check. Is the cable working or not? And is there's a fail in the cable, as you saw on the layout over here?
Yeah.
These little LEDs fits between the pin rows. So I can tell this would be in a good cable. All of them would turn green.
Yeah.
And if something isn't connected, well, it won't turn green.
Yeah. I think we need to test this on a few different cables because I have seen some HDMI cables where not all the pins are connected, but they work.
Yeah. So this would be a thing where we say, okay, this cable is still good, even if whatever isn't connected.
And we have to do that by trial and out. Experimentation. We try a number of different cables. Yeah. Okay.
I dropped in 3 buttons just for having them there because, available space. I don't know if we're ever going to use them. Maybe there will be some switching and testing, blah, 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 blah. But for me right now, I guess this would be a one-time job. Because what we've in my mind for that is it's a project where it's say, okay, this is on the fence in complexity to do this on a channel like this.
Yeah.
For I don't know how many of you guys will ever build this. We probably release the source code, we release the Gerbers, and I don't know how many people of you will say, okay, we're going to build this. So
but it's fun.
Yeah.
It's fun. It's fun. We were actually chatting about the software and how to do the detection. Now, I have worked as a programmer before, and I came up with an idea that I could draw this on paper, but it's probably easier here. So effectively, if we have a high on this pin, we should see a high on that pin. And the same one, a high on this pin, should give a high on that pin. But there's also the possibility we have a short between 2 pins. So my idea was initially that we just put a high on this pin, all the rest are low. And then in the software, we look for a high coming back. But as Det says, they're not in the same order. because of the routing. So I think what we should do, as we were discussing, is to effectively connect a cable, one end to the other, on the board, and then we write some software that puts a high on here first, and we see what comes back. And then the same for the next one, and we see what comes back. And after we've done all 19, we should have known 19 good results. Okay. So my general idea is effectively we have like a lookup table.
Yeah, like a fingerprint.
Like a fingerprint, so we know what should be the good result for each pin being high. But again, what do you guys think? Do you think there's perhaps an easier way to do that? Or?
Well, my idea was writing a function where you say, okay, I want to check this pin against this pin, and it automatically checks the other pins if there's some movement on that.
Yeah.
For this, we have to switch them to input state with a pull-up and read every one of them. This is not in our range because I would put a low on the test pin, and if I see that something other moves, I know there's a problem.
Yeah. If something else changed as well. Yeah.
We have to figure this out. This is the thing that will happen when we try this out. This will be. You said, "Come on, let's do the software together." This sounds like a fun idea.
Exactly. So that's where we are with this. Now there was other ideas with this. So I had a company who process a lot of graphics cards. They are buying used and reselling used graphics cards. They're actually the largest supplier in the USA of used graphics cards, and he was asking me if we could make something that effectively he could connect some sort of tester to the HDMI out or DisplayPort out on a graphics card, and it tells him if the hardware is okay. So not that the graphics card's okay, but the port itself is okay. So Detlef and myself were discussing this, and we haven't really come to any exact method yet by which we could test. I'm thinking probably the best way is to start probing around. I have a lot of graphics cards here and see what we can see.
Yeah.
But again, you guys, what do you think? Do you think it'd be possible? Because surely it's just software, isn't it? Have we changed the software on this tester?
Yeah, the problem here is, I think, is that is all differential. You know, TD0, TD0 plus, TD0 minus, and the shield. This is something that is a differential input. So we only can test probably for what's his face? Electrical characteristics.
Yeah. But if you look at, for example, like PCIe is the same. So with the graphics card, you have 19 lanes. But I've done this many times on video. So if I use my multimeter on each lane in like a reverse polarity to the normal, I can see a diode junction on each of the lanes on the two differentials, the plus and minus signal. And if one reads different to another, I can't say what the reading should be, but they should all be the same for each lane. And also they shouldn't be shorted to each other. So I'm thinking maybe that sort of test. And that actually brings me to something else. So because I'm always trying to put more work on Det's plate, could something like this, for example, to be made into kind of a go, no-go SATA port tester for motherboards. You just effectively click it onto each port with the motherboard powered down. And at least it will tell you electrically if it looks okay, rather than the same as sending data.
These tools doesn't exist, right?
No, these tools do not exist. And I wouldn't say it gives you an absolute. I'd say if you've got a faulty SATA port, it will tell you it's faulty. If it doesn't tell you it's faulty, it doesn't necessarily mean it's good.
Well, since SATA is PCIe
and PCIe and SATA are both LVDS, and for that matter, so is USB.
Sure. And
USB 3 has 3 LVDS. It might be possible to kind of like make versions of this effectively for plug into any sort of LVDS board. And as I say, I think it will tell you if you've got a bad one, and if it isn't bad, it doesn't necessarily mean it's good, because it could be something else wrong that you can't see. But anyway, guys,
I think we'll learn on this one.
I think we'll learn a lot.
A learning experience, and from there, if we find that we can successfully and on the point that we can pinpoint, okay, this is a working port. From there on, it's easy, because the technology from there is the same now. Yeah,
it is exactly, because almost everything uses LVDS these days. I mean, HDMI, SATA, USB, PCIe are all much more similar than you guys may have realised in the implementation, the way they work. So, anything else you want to add to that, Deb? And then we'll put a call to action to you guys. Let us know what you think about all this, because it's all up in the air at the moment. So, Dad.
What I would say, or what I would ask you guys, we have some strange chips on here. When I told Richard about the MCPs 27017, he said, what?
Do you want to get the data sheet for that on the screen?
We could.
Okay.
So, snap, there's our data sheet. When Richard saw this, he said, "Wow, this is an interesting chip. How I never used this." And I said, "We used them in university. We used them. We have built this big sampler with 32 set channels, and this was actually used to control big valves. Well, not from the chip. The chip can't drive this. We put some MOSFETs in there.
Yeah. Not ULN233s?
No, not enough current.
Okay.
And we use this a lot, and this is a great chip. And I said, this is reliable, this works, it's out of the box, there's a great library for that, you simply use it and bam, Bob's your uncle. And I thought, maybe you guys don't know about these chips, and I could do a little thing where I simply go for, okay, have a look at this strange chips. It's same with the VS2812 LED things.
Okay, and
you used them before in a different project I can't talk about.
And the one I saw, which was the I2C potentiometers.
Yeah. Well, I have experience with these. I can tell the people about these.
Excellent. So what you're thinking, Jet, is on your channel to have a feature.
Strange devices.
Strange devices explained.
Yep.
Yeah.
This is something for you guys. Let me know in the comments, please.
Yeah, what do you think? So that's something for Det's channel. Or would you be interested in like device of the month or something like that?
Device of the month, okay. with a fold-out pin?
Yeah.
Oh, nice.
With a plug pin, yeah.
We're back to naked chips.
So, guys, let us know what you think. I mean, if I can make Det work harder, we'd have device of the week, but I don't think it's going to work that hard. Yeah, so I hope you guys will agree. That's really an interesting idea.
I think so, yeah. This would be my pickup here. And we did the design. I think it's already in production.
Yes, the PCBs. Yes, so PCBWay have the design now. It's not in the shared projects yet, but as soon as we prove the concept actually works, obviously it will be.
It won't help you guys. We have to find out if it works first. So I'm pretty sure I nailed it on the spot, but the devil's in the details.
The devil's in the detail, yeah. So there you have it, guys. Let us know what you think. I'd just like to thank PCBWay for sponsoring these videos. Without their help, we couldn't do this sort of thing. And of course, thank Detlef for his input once again.
Thanks for having me, mate.
And thanks to you guys for watching and hopefully getting involved with this.
Yeah. Let us know what you think. We're open for suggestions here. This is not a finished project. If you have ideas how we can improve on that, please go.
Yep. Okay. So from Detlef and myself, ciao for now.
Ciao for now, guys.